Hey there, welcome back to the channel. My name is Chris, and today I want to just talk real quickly about making late-stage hardware changes. I have this transfer case controller that I made for a customer, I don't know, at least 6 months ago. They're doing a custom build for a vehicle, basically a hot rod. They needed a controller for a transfer case. The model doesn't really matter. This actually works for two different models because I had done one for them previously for a similar but slightly different transfer case. For those who don't know, a transfer case is the thing that when you put the vehicle into four-wheel drive, it connects the drivetrain to the front drive shaft, basically. So this allows you to determine, what gear you're in. In fact, I have a switch here that allows me to simulate whether we're in 4 low, 4 high, 2 high. This is just different resistors. It works the same way as the one in the vehicle. The one in the vehicle is a Ford 3-position switch. So ship this to them. Everything worked. They were assembling the vehicle, and it turned out that one thing that they did not think of was the hubs all the way out at the front wheels have to be engaged in order for it to go into four-wheel drive. So this will control the transfer case, which will then send power to the front drive shaft and basically to the front differential. But if you don't lock the hubs out at the wheels, then it actually doesn't go into four-wheel drive. So you're driving the front drive shaft, but not the actual wheels. On this vehicle, those are automatic, or at least they're electronically controlled. In the normal vehicle, they're automatic, so when you select it, it would go into four-wheel drive and lock the hubs. But for this case, they have to control that, and this controller didn't do that. So the question is, really, I have designed this piece of hardware, right? And how do we get this hardware to work for that without having to respin a whole new board? You might notice it's got this wire on here. This is part of my hack, my workaround. So what I did was I first said, okay, well, how am I going to control what the vehicle needs, right? So the way the hub works is somewhere out at the vehicle, it's got 12 volts out at that hub. And the signal wire comes back from that hub, and it needs to drive that to ground. So we need to drive this to ground when we are in four-wheel drive and leave it floating when we're in two-wheel drive. We already have a selector, so our application running here knows when we're in either two or four-wheel drive when it's been selected. So really all I have to do is, in software, be able to control something that switches this to ground. Now this is 12 volts, and this is, 5-volt tolerant, but it's driving at 3.3 volts for logic. So we can't just, run the 12 volt into one of these inputs and then have that go to ground. I wouldn't want to do that anyway because I don't know how much current it has. They did measure it and they said it's only about 30 milliamps of current. But then they said, oh, well, we're also going to hook this up to the cluster indicator. So the light on the dash, so that when you put it into four-wheel drive, it turns on a light that says you are. If that's incandescent, there are a lot of unknowns. So I wouldn't want to drive 12 volts right through here. Even if it were 5, I probably wouldn't want to drive it. So we need to have some circuitry here that we can adjust this here and make it work. So really what you want to do is you want to go through a transistor, right? So we can come through a transistor. And so basically what we're doing is we are able to switch. This is to ground. So we have 12 comes through this transistor, and I'll use a 2222. And then we can switch this, so we can use 3.3 to switch this 12 volt. So this is our kind of our enable signal here. And this is probably 330, 470, somewhere in there. I'll probably put in a 330. So I can take this and it'll drive to ground. So when we turn on this enable, it will close this and drive this. A 2222, I believe, will take 800 milliamps of current, and they said it's at about 30. So this should allow us to be able to drive those hubs, as well as any indicator lights and things like that. So really, all I need to do is I need to build this. So what I did was I just built that on a separate circuit board. Ideally, this would have been on this one originally, but they already have this, but I'm going to have to ship them a new one. The point is they've already got an enclosure that they've built for this, and we don't want to have to wait a couple of weeks for me to ship one or order, basically design, order, get them shipped to me, assemble. It's a whole bunch of work and expense. So what I did was I just created this, which is this here. And then this is ground, the black one. This red is our enable bit, and it runs through this resistor to the 2222. And this is where they can hook up their 12 volts. I gave them 3 positions here. They're just all connected together down there so that they can hook up the hubs, an LED or a lamp or something like that to indicate they're in 12 or in 4-wheel drive. And then they've got a spare one for whatever. So by doing that, then I just flip this over and I ran this to an output. So I soldered it to an output that was not used on this F7 microcontroller, and then to ground. So this allows me to ship this to them. They can put this in the case where the other one is, take this, find some place to mount it and plug it in, and then just add 1 more or 2 more wires here. So this allows me to do a late stage change after we've already designed all of the hardware and everything for this transfer case controller. So what's the lesson here? Well, the lesson is that hardware is hard, right? If you're doing software, if you make a mistake, you need to make a change after it's deployed. It's pretty easy to do. Hardware, if you need to make a change, it usually involves solder, wires, a bunch of other things, as well as software. So there was a software change here for that output. But I have to ship something to the customer that they can put into a vehicle. They want a fairly quick turnaround time, so you don't always have time to order new boards. So you have to learn to think outside the box and how it is that we can adjust these. A little bit of foresight on my part could have made the controller board itself a little bit more extensible. I probably should have had a couple of GPIOs just come out to pins that in case I needed them, it would have been a little bit easier. Wouldn't have had to solder on. Could have just shipped them this other little board without having to do this hack. Things like that. The lesson is software is different than hardware. And when you're doing hardware, you're going to run into challenges like this. So you have to be able to work around them. That's all I got for you today. Thanks for watching.